Hey kiddos, today we're going to do a quick little radical refresher. We actually kind of did a refresher when we did our algebra review. So kind of hitting back on this because I know that algebra review was first semester. So adding and subtracting radicals. First thing you have to do is you have to simplify each radical first. Very, very important that you do that first. After you do that, then you can combine. Now, the only way you can combine, which basically means you add or subtract, are the radicals that are alike. So it's kind of like combining like terms. Okay? And when you combine like terms, you only change the coefficients, basically. You only add or subtract the coefficients. The radical stays the same. So looking at the first example, all of these terms have the same radical, so that means that they're alike, which means I can combine their coefficients. So 6 plus 5 is 11. 11, take away 3, leaves me with 8. And the radical part stays the same. I don't mess with it, okay? Moving on to the next one, example 2. Now, also, just a little side note here. Because these were square roots of 7, I knew that they were already simplified. You can't simplify square root of 7 any further. So, example 2. Square root of 50 and the square root of 32. Yes, they can be simplified, so we have to do that first. Now, here's where some of you learned a different method than what I taught. I think you guys called it the birthday cake method. And that's cool. If you like that method and you get it and you got it, keep it. Okay? I don't do it, but if you got it, no problems. I like to do factor trees. So, I need to do a factor tree for 50 and for 32. 50, I got 5 times 10. 10 breaks down to 5 times 2. Squiggle out what I broke down, so squiggle you out. Finding pairs and what's left over. Pair of 5s and a 2's left over. So, square root of 50 basically breaks down to 5 square root of 2. Now let's look at 32. 32, 8 times 4. 8 breaks down to 4 times 2, and that 4 breaks down to 2 times 2. And this 4 also breaks down to 2 times 2. We broke down a lot of things in this one. So I'm going to squiggle out the ones that I broke down so I don't get confused. Looking for pairs. Got a pair of 2's there, got a pair of 2's there, and I even have a 2 left over. Multiply pairs, so 2 times 2, 4, square root of 2. What's left over goes inside. So, now to work it back into our actual problem, keep in mind here, and this is where some people are going to make a mistake. The square root of 50 actually has a coefficient, so you can't forget about that, okay? That coefficient is going to be multiplied to our coefficient of when we simplify the square root of 50. So when I rewrite it, it'll look like this. 2 times 5 square root of 2 minus 3 times 4 square root of 2. All right, now we're going to break that down. 2 times 5 is, so you get 10 square root of 2. Negative 3 times 4 is negative 12 square root of 2. And what do you notice? Because they both have square roots of 2's, we can combine these. So 10 minus 12, you just deal with the coefficients. 10 minus 12 is negative 2. And then the square root part stays the same. You do not change it. All right? Let's look at the next example. Looking at 27 and 48. So let's make our factor tree. Two numbers multiply 27, 9 and 3. 3 doesn't break down any further, but 9 does. So 3 times 3. Squiggle you out, squiggle you out. I have a pair of 3, and then 3 left over, so that gives me 3 square root of 3. 48. 8 times 6. All right, so 8 breaks down to 4 times 2. 4 breaks down to 2 times 2. 6 breaks down to 2 times 3. Squiggle out what I broke down. All right, we got 1 pair of 2, 2 pairs of 2s, and a 3 left over. So multiply the pairs. 2 times 2, 4, square root of 3. All right, now plugging it back into our original problem. Square root of 27 was the 3 square root of 3, so we get 3 times 3 square root of 3 plus 5 square root of 48 was 4 square root of 3, so 5 times 4 square root of 3. All right, let's actually do that multiplication part first. 3 times 3 is 9 square root of 3 plus 5 times 4, 20 square root of 3. Well, because they do now have like radicals, we can combine these. So 9 plus 20 gives us 29 square root of 3, and that would be our answer. All right, now let's go to multiplying radicals. So, multiplying radicals, we multiply the coefficients, and then you multiply the radicals, or I should say, the radicands, and then you simplify them, okay, if possible. So, 2 times 3 is, whoa, I didn't mean to do that. 2 times 3 is 6, and then 8 times 7 is the square root of 56. So from here, we look to see if we can simplify the radical of square root of 56. Again, I like the factor tree method. I'm not going to break my mind and figure, oh, what 2 numbers multiply 56? Because we just multiplied 2 numbers to get that, and that was 8 and 7, okay? So from there, let's break it down. And 8 does break down to 2 times 4, and 4 breaks down to 2 times 2. All right, squiggle out U, squiggle U out, squiggle U out. Pairs. Yes. Got a pair of 2s, and then we got a 2 and a 7 left over. Okay, so basically that breaks down to 2 square root of 2 times 7, 14. Now, when I plug it back in, don't forget about the 6, okay? 6 times 2 square root of 14. 6 times 2 is 12. Keep the square root of 14 because there's no other radical to multiply it by, so the answer would be 12 square root of 14. Next example. Same concept. We got 2 times 4 here, which is 8. Square root of 5 times 20 is 100. If I'm not mistaken, I like seeing numbers like 100 or 81, 25, 16, because they're perfect squares, which means they make our life 10 times easier. So we already know that the square root of 100 is going to break down to 10. So really, problem is 8 times 10, which is 80. No radical than that one. All right, next example. So we got the square root of 7, and it's being squared. So notice, remember, we can always rewrite that problem to read as square root of 7 being multiplied by the same square root of 7. Okay? Square root of 7 times square root of 7. So I'm going to show you mathematically what the answer would be before I show you the shortcut. Square root of 7 times square root of 7 is equal to square root of 7 times 7 is 49. 49, again, that's a number that we like because it's a perfect square. Square root of 49 is 7. So here's a little shortcut. Anytime you multiply 2 radicals that are the same, they basically just break down to whatever number's in the radical. Okay? So if it were to be square root of 2 times square root of 2, the answer is 2. Square root of 3 times square root of 3, the answer is 3. Okay? So keep that in mind. It's a nice little shortcut, but still, mathematically, you can still work it out. Next one. The square root of x times the square root of x. Well, square root of x times square root of x would be square root of x squared. And we hopefully know that square roots and squares cancel each other out. So again, you would be ending up with just x. All right, time to divide. When we're dividing radicals, first thing you do is you divide coefficients. Okay, you reduce your coefficients if you can. Then from there, you look to divide the actual radicands, okay? Can you actually divide the radical? And that means that they divide perfectly. No decimals or anything like that. They have to divide perfectly if they do. If not, then you got to rationalize, or we actually got to break down, I should say, those radicals, okay? And then see what we can do from there. And we also have to rationalize the denominator because remember, you can have no radicals in the denominator. So 56, square root of 56 divided by square root of 7. First thing you look to see is, does 56 divided by 7 break down to a perfect value? The answer is yes, and that is awesome for us. And in this case, it does. So 56 divided by 7 is 8. So we end up with the square root of 8. Now you're not done though yet, because technically can't we break down square root of 8? I think we can simplify that. Here's my factor tree to prove it. You get 4 times 2. 4 breaks down to 2 times 2. Squiggle you out, squiggle you out. We got a pair of 2's and a 2 left over. So that results in 2 square root of 2 as the answer. All right, example 2. Square root of 6 divided by square root of 7. 6 divided by 7, that does not break down perfectly. So, and you can't even break those down anymore. Like, they're already as simple as they're going to get. So, how do we get rid of that radical in the denominator? Easy. What you do to the bottom, you must do to the top. So, we will multiply the numerator and the denominator. Yes, you said it, you guessed it right, by the radical that's in the denominator. So, we're going to multiply numerator by square root of 7 and the denominator by square root of 7. So, multiplication is easy, you multiply straight across. So, 6 times 7 gives me the square root of 42 over, don't forget our little shortcut there, square root of 7 times square root of 7 is just 7. Notice we got rid of the radical in the denominator, which is what we wanted. All right. So, question is, can we break down 42 though? Now, we already know that 42 is 6 times 7. We know 6 breaks down to 3 times 2. And 7 doesn't break down any further, so those squiggle out, I got no pairs. There's nothing I can do. So, you can't simplify square root of 42. So therefore, that would be the simplest form that we can make that answer. So the answer for square root of 6 divided by square root of 7 is square root of 42 divided by 7. Next one, example 3. All right, remember, you cannot divide coefficients or whole numbers basically with radicals. Not happening. So automatically, we got to get rid of the square root of 12 that's in the denominator. And the only way to do that is just like the previous problem, by multiplying the numerator and the denominator by the radical that is in the denominator. So 3 times the square root of 12 is just 3 square root of 12 over, we already know that square root of 12 times square root of 12 is going to just be 12. So no more radical in the denominator. Perfect. Now we look to see if we can reduce the coefficients here, the 3 and the 12. 3 divided by 12 does reduce to 1, so don't forget the square root of 12 though, over 4. Or if you wanted to rewrite the answer, it's really just square root of 12 over 4. Yay! Alright, now this is probably going to be the most important part of this whole notes, because it's going to be used, you're going to use this when it comes to solving our special right triangles. Alright? So solving for a variable with radicals. Okay? So first example, you have x square root of 2 equals 14. This is just like solving equations. Okay? What you first have to recognize that's happening here is that this is a multiplication problem. It's x times the square root of 2. So we got to get x by itself, essentially, is what we're wanting to do here. Okay? So you have to think of, well, if this is multiplication, the opposite would be to divide both sides by that square root of 2. So when I work this out, yeah, those cancel out, and that's what we want. And you get x equals 14 over the square root of 2. Well, we know that can't be the right answer because you can't have a radical in the denominator. So here's where the little extra steps come into play. I got to multiply here now, the top and the bottom, by the radical that's in the bottom, which is square root of 2. So we get 14 square root of 2 over square root of 2 times square root of 2 is just 2. Now, let's reduce the whole numbers. 14 divided by 2 reduces to 7. Don't forget the square root of 2. So, x equals 7 square root of 2. Let's look at another problem. Example 2. Similar concept. Got to get x by itself. So this is x times square root of 3. So to get rid of that square root of 3, I got to divide it. What I do to one side, I know I do to the other side. Those cancel out, and I'm left with 6 square root of 2 over square root of 3. Cannot have the square root at the bottom. So I got to multiply the numerator and the denominator by the square root of 3. So I end up with 6 square root of 6, because 2 times 3 is 6, over square root of 3 times square root of 3 is 3. All right? 6 divided by 3 reduces to 2, and don't forget the square root part of 6. So x equals 2 square root of 6. Let's try another. Same concept. Got to divide both sides by the square root of 7. Those cancel out. Perfect. But we can't have a square root of 7 on the bottom, right? So we're going to multiply the numerator by the square root of 7 and the denominator by that square root of 7. So I get, when I multiply across, 14 square root of 7 over square root of 7 times square root of 7 is just 7. Look to reduce. 7 goes into 14 twice, so we end up with 2 square root of 7. X equals 2 square root of 7. Next one, example 4. Same concept, so hopefully you guys are seeing like it's the same steps over and over here, okay? Gonna divide both sides by square root of 11. Those cancel out, but again, can't have a radical in the denominator. So I'm gonna multiply the numerator and the denominator by square root of 11. Why do you ask square root of 11? Because it's what's originally was in the denominator. Okay, so I don't make this up. I get it right from here. So multiply across, we get 22 times square root of 33 over square root of 11 times square root of 11 is, yes, you said it, 11. Reduce, actually, yeah, that does reduce. 22 divided by 11 reduces to 2 square roots of 33. So x equals 2 square root of 33. Good job. Way to pay attention. Way to do your work.